So stoichiometry is majority of chemistry's calculations. If you are going to write Jamb chemistry, you have to have a great knowledge in stoichiometry to keep you on the safer side. So in this video, I'm going to go from the basics of stoichiometry, then we'll go to deeper calculations in stoichiometry, and then we'll go to a test process where I'll give a question, you try to solve it, and then I'll give the answer. Then you can use to rate yourself on your knowledge in stoichiometry. All right. My name is Wisdom Richman. I'm a petrochemical engineering student of the Federal University of Petroleum Resources, and on this channel I teach chemistry, so consider subscribing for more Jamb chemistry videos like this. Alright, without any delay, let's get straight into it. So now the basics of stoichiometry, what you have to learn is, number one, the atomic masses of the elements. Okay, when I was in secondary school, I tried to familiarize myself with the atomic masses of the first 20 elements, and this helped me a lot in my chemistry exams. So you should try that too. You should try to get that too. Just try to memorize the atomic masses of the first 20 elements. Although in some questions like this one now, they can give you the atomic mass, but it is not guaranteed. I won't advise you put your hope on that. So go and memorize them so that you'll be on the safer side. Now, the next year on the chemistry basics is how to calculate simple calculations such as empirical formula, simple calculations such as relative molecular mass, simple calculations such as percentage composition, and how to calculate the mole and all that. So we are just going to go to some few examples on it, and after that we'll be done with these basics. All right. Okay, so calculating relative molecular mass of aluminium tetraoxosulfate 5. Okay, so aluminium is 27, that's the atomic mass. Sulfur is 32, oxygen is 16. Okay, so with this now we'll be able to calculate the total mass of the whole compound. So since we have 2 atoms of aluminium, we're going to say 27 times 2, then we add that to the, okay, so sulfur is 32, oxygen has 4 atoms, so we are going to say that is 4 times 16. Then we multiply everything by 3. Okay, so for this we have 54. Here we have 32 plus 64, and then we are multiplied by 3. 54 plus, we have 96 here. We multiply everything by 3. So 54 plus this, which will give us 288, and the total mass will be 342, the relative molecular mass of this compound. So also go and check for these compounds I'm writing out now. Try to calculate their relative molecular masses. Alright. Okay, so calculating the percentage composition of each element in calcium hydroxide. So this is a chemical formula of calcium hydroxide. So if calcium's atomic mass is 40, that of oxygen is 16, and that of hydrogen is 1. Okay, so 40 and then 16 plus 1, we are trying to calculate the relative molecular mass of calcium hydroxide. So we can see that the total relative molecular mass of it is 74. So to calculate the percentage of each element, we have to divide the mass of that element by the total mass, then multiply by 100. That's the way we'll be able to calculate it. So for calcium now, its mass is 40, we divide it by 74, multiply by 100, then we'll have the percentage of calcium as 54.1%. I will do that for oxygen too. So this oxygen has 2 atoms here, it has 2 atoms, so we are going to say 16 times 2, this is 32, we divide it by 74, then multiply by 100, which will give us the percentage of oxygen. Okay, then also for hydrogen has 2 atoms too, so which is 1 times 2, which is 1 times 2, which will give us the total mass as 2. So 2 over 74 multiplied by 100 will give you the percentage of hydrogen in this compound. Alright, so you can also try it for compounds that I'm writing down. Just calculate the percentage composition by mass of each element. So the mole, these are the different definitions of a mole, so a screenshot will be very helpful here. Okay, so we have the first calculation of a mole as reacting mass divided by the molar mass, that is the mass available in the question divided by the molar mass. that is the mass of it, mass of 1 mole of that substance. So it can also be calculated by the number of particles or number of atoms divided by 6.02 times 10 raised to the power 23, which is called the Avogadro's number, which is written as Na as its symbol. Okay. Now, what is the mass of 3 moles of oxygen? So 1 mole of oxygen is O2. This is because oxygen is diatomic. Oxygen is diatomic. Other diatomic molecules are as follows: H2 molecule, the N2 molecule, the C2 molecule, and the Cl2 molecule, and so on and so forth. So 3 moles of oxygen is 3O2. It's written as this. Now we know very well that the mass of oxygen is 16. That is the atomic mass. That is 1 atom of oxygen is 16. So now 3 times 2, that will give us the total number of atoms of oxygen, which is 6. So for us to calculate the mass of these 3 moles, what we'll do is 16 times 6, which will give us 96 gram. That is the mass of 1 mole of oxygen. So how many moles are in 30 gram of calcium chloride? So we are calculating the relative molecular mass of the molecule of calcium chloride to give us the molar mass. That is the mass of calcium chloride in 1 mole. Okay, so you can see that it is 111 gram. So reacting mass over the molar mass will give us the mole. So the reacting mass in the equation is 30 and the molar mass is 111, which will give us 0.27 mole. Now find the number of atoms in 0.23 moles of aluminium. If 1 mole is 6.02 times 10 raised to the power of 23 particles or atoms, then 0.23 mole will give us what? So the normal mathematics trick, we have x is equal to 0.23 multiplied by 6.02 times 10 raised to the power of 23. So we have this as 1.4 times 10 raised to the power of 23 atoms. But normally, if you have different examples of number of moles as this, just simply multiply it by the Avogadro's number and you have the respective number of particles or atoms and so on. So a compound is found by analysis to contain 65.45% carbon, 9.09% hydrogen, and 25.45% nitrogen. Calculate its empirical formula if the relative atomic masses of the elements are as follows. So I'm writing down the procedure for calculating the empirical formula. We start from elements, percentage composition, then a mole ratio, which is calculated by the reacting mass over the molar mass. Then the fourth step is divided by the smallest, and the last step is the whole number ratio. Okay, so I want to just draw the plane. So this is for 3 elements. Okay, so the elements, the first element is carbon, which is C. Second element is hydrogen, which is H, and then nitrogen, which is N. So the percentage composition by mass, according to our question, 65.45 for carbon, 9.09 for hydrogen, and 25.45 for nitrogen. So now to calculate the mole ratio, that is just like calculating the mole. So we divide 65.45 by the relative atomic mass. So what to do is 65.45 divided by 12. Now for hydrogen, 9.09 divided by 1. For nitrogen, we have 25.45 divided by 14. Okay, so what we have here, so in the first case we have 5.45, in the second case we have 9.09, in the third case we have 1.82. So then we divide it by the smallest. So the smallest is 1.82, so divide the first one by 1.82. We divide the second by 1.82, and we divide the third by 1.82. So now the answer is going to be this. For the first case we have 3, for the second case we have 5, for the third case we have 1. So this is a simple whole number ratio. So we are going to write down the empirical formula as C, which is 3, H5 and N. Since N is 1, we don't write the 1. So this is the empirical formula. So an organic compound on analysis yielded 2.04 gram carbon, 0.34 gram hydrogen, 2.73 gram oxygen. A, calculate the empirical formula. So the first element is carbon, then hydrogen, then oxygen. Present composition by mass, or just simply the reacting mass: 2.04 for carbon, 0.34 for hydrogen, and 2.73 for oxygen. So the mole ratio now, we divide 2.04 by 12 for carbon, 0.31 divided by 1, and 2.73 divided by 16, since 16 is the relative atomic mass of oxygen. Alright, so now we get the respective answers. Then we divide by the smallest. So the smallest here is 0.17. So we divide 0.17 by 0.17 to give us 1, 0.34 by 0.17 to give us 2, and 0.17 by 0.17 to give us 1. So you can see that the simple whole number ratio is 1 to 1. Alright, so we write down the empirical formula. Write down the empirical formula as CH2O. Okay, so remember they also told us to calculate the molecular formula. If the relative molecular mass of the compound is 60. So the relative molecular mass of the compound is 60 gram, and we should know that the molecular formula is a multiple of the empirical formula. So we are going to say CH2O multiplied by N is equal to 60 gram. So if we do this, we'll be able to find the N, and then if we multiply the N with the empirical formula, we'll have the molecular formula. So I'm calculating the relative molecular mass of the empirical formula. So I have 30 N equal to 60. By normal mathematics rules, I have N equal to 2. So I multiply the empirical formula by 2, and if I simplify that out, I have this as the molecular formula. So this is the molecular formula. But since this is an organic compound, it can also be written as CH3COOH. Calculate the empirical formula of an organic compound containing 81.8% carbon and 18.2% hydrogen. Okay, this is the last question for empirical formula. I just want to show you a final step in empirical formula. Okay, so write down the percentage composition by mass, then the mole ratio, which is reacting mass, over the molar mass, that is the atomic mass. So what we are going to do is 81.8 divided by 12, 18.2 divided by 1. So we divide it by the smallest number. So for this now we have 6.82. For this we have 18.2. So we divide everything by 6.82, which is smallest, to get the whole number ratio. So we have 1 in the first case. For the second case we have 2.67. Now you can see that 2.67 is not a whole number. So we multiply everything by 2. That is the first whole number ratio we got. So the next one we got still not a perfect whole number. So multiply the first one by 3 again, which will now give us 3 for this one, and 8.01. So this is very close to a whole number. So take that as the empirical formula. So this is the step I wanted to show you. So now it's time for deeper calculations. Now in these deeper calculations, I'm not going to just teach it with just words. We are going to learn hands-on. As we are doing calculations, we'll be able to learn them. So we're going to go straight into that. What mass of lead 2 trioxynitrate 5 will be required to yield 12 grams of lead 2 chloride on addition of excess sodium chloride solution? So this is the equation of the reaction. So the relative molecular mass of lead 2 trioxynitrate 5 is 331, and that of lead chloride is 278. So if 331 gave 278 from the equation, then what will give us 12 grams? So simple mathematics cross multiplication method, we have this as the answer. In the industrial preparation of trioxynitrate 5 acid, ammonia gas is bound in oxygen in the presence of a catalyst according to the following equation. Now, if 250 centimeter cube of ammonia is burned completely, what volume of oxygen is used up? Okay, so from the equation, 89.6 decimeter cube of ammonia reacted with 112 decimeter cube of oxygen. So 250 centimeter cube of ammonia will react with what volume of oxygen? Okay, but you can see that the former volumes were in decimeter cube, so you have to convert them to centimeter cube by multiplying it by 1000. So you multiply decimeter cube by 1000, you give centimeter cube. So we have this in centimeter cube now. Okay, so if this volume of ammonia gave this volume of oxygen, then 250 will give us x. So by normal cross multiplication methods, we have the answer as this: 312.5 centimeter cube. So the next is the amount of nitrogen 2 oxide produced. So if this volume created equal volume of nitrogen 2 oxide, then definitely 250 centimeter cube also produce 250 centimeter cube of nitrogen 2 oxide. 50 centimeter cube of carbon 2 oxide is mixed and sparkled with 200 centimeter cube of air containing 21% of oxygen. If all the volumes are measured at STP, calculate the volume of residual gases. So if 200 centimeter cube of air but 21% of oxygen, so if I calculate 21% of 200 centimeter cube, I have 42 centimeter cube. Okay, so I subtract that from 200, I will have the first residual gas, which is the remaining part of air, which is nitrogen and the rare gases. So I'm going to write the equation of the reaction, which is carbon 2 oxide plus oxygen will give me carbon 4 oxide. So I try to balance that by putting 2 and 2 there. So it's 2:1:2. So before the reaction, know that this is 50, this is 42, and we don't have this yet before the reaction. So when they are reacting, since this is 50, since oxygen is half of carbon 2 oxide, to be 25, and since this is also 2, so it will be 50 centimeter cube for carbon 4 oxide. Then after the reaction, we know that carbon 2 oxide has definitely been used up. Then that of oxygen is only 25 that reacted, so 17 will remain, and carbon 4 oxide is 50. So the total volume of residual gases will be the volume of oxygen not used plus the volume of carbon 4 oxide produced for the residual gases of air, which that will be 17 plus 50 plus 158, which will give me 225 centimeter cube. What volume of dry oxygen gas measured at STP will be produced from the decomposition of 3.50 gram of potassium trihydrochloride 5? So this is the equation of the reaction. So I have to calculate the relative molecular mass of potassium trihydrochloride 5 in the equation. So this is this. I multiply by 2 since there are 2 moles of potassium trihydrochloride 5, which will give me 245 gram. Okay, so the volume of oxygen produced from 245 gram is 67.2. Okay, so you can see how I did it. I multiplied 3 by 22.4 decimeter cube. Okay, so 8245 will give me 67.2, 3.5 will give me x. So the normal cross multiplication method will give me 0.96 as the answer. What volume of 1 molar concentration of hydrochloric acid will be required to react completely with 3.25 gram of zinc? Okay, so the mass of zinc in this equation is 65. So you calculate for hydrochloric acid, which is 36.5, multiply that by 2, which will give us 73. It's reacted with 65 gram of zinc. Okay, so what will react with 3.25 gram of zinc? So the normal cross multiplication method again, and we have our answer as 3.65 gram of hydrochloric acid. But we were asked to find the volume. 1 molar concentration of hydrochloric acid. Okay, so molar concentration is mole per gm cube, which is the mole divided by the volume. So if the mass of hydrochloric acid is 3.65, we divide by that by the relative molecular mass to give us the mole here, which is 0.1 mole. So 1 molar concentration will be equal to 0.1 divided by V, and which will give me 0.1 decimeter cube. So we convert it to centimeter cube by multiplying by 1000, which will give us 100 centimeter cube for the volume. Okay, so now it's time for our test process. Okay, that is, I will give a question and then you try to solve it and check the answers I will give at the end. So these questions are from Jamb past question, that is Jamb chemistry past question. So you'll be learning as we are going. So pause the video, try to answer it before checking it. All right. So first, to write out the equation of the reaction and make sure it is balanced. Okay, this is a 2. Okay, all right. So before the reaction, we're told that hydrogen is 50 centimeter cube, oxygen is 20, and then you can see that we don't have water yet. And now during the reaction, we can see that hydrogen to oxygen is 2:1. So to make that possible, hydrogen will have to be 40 and oxygen 20. Okay, and since water is also 2, it is 40. Now The remaining one of hydrogen is 10. That of oxygen has been used up. So we add 10 to that of the 40 produced to give us 50 centimeter cube. So pause the video, try to answer it before checking it. Alright? So oxides are binary compounds with oxygen and another element only. So since nitrogen is 30.4%, definitely the remaining percentage will be taken by oxygen, which is 69.6%. So that will be the percentage composition by mass. So the next step is the mole ratio, okay? But an important thing to notice is that you are divided by the atomic masses, okay? So in the first case, you divided by 14, since that's the atomic mass of nitrogen, and for oxygen divided by 16. So we have 2.17 for the first one, and we have 4.35 for the second one. Then we divide it by the smallest. So we divide all by 2.17, which will give us 1 for the first case and 2 for the second case. So the whole number ratio is 1 to 2. So the empirical formula is NO2. Okay, but again, try to pause the video, answer it before checking it. So first to write out the equation of the reaction, which is this. Okay, so the mass of phosphorus here, since phosphorus has atomic mass 31, multiply that by 4, which will give us 124 gram. So 124 gram required 160 gram of oxygen. Okay, so if 124 gram require 160 gram, 12.4 gram will require X. By normal cross multiplication method, we have X, which is the mass of oxygen, as 16. But remember, you were asked to find the liter, which can only be calculated when you have the mole first, okay? Since liter is volume. So the molar mass of oxygen is 32. Since oxygen is diatomic, that is 16 times 2. So with that, we can now calculate the mole by reacting mass over the molar mass. So since 1 mole of a gas contains 22.4 decimeter cube, I multiply the mole by 22.4 to give me 11.2 decimeter cube. So 1 decimeter cube is equal to 1 liter. Then that means 11.2 decimeter cube equal to 11.2 liters. Why did I say so? Since 1 decimeter cube is 1000 centimeter cube, and that is 1 liter. Try to pause the video, answer it before checking it. So here's a chemical formula for sodium carbonate, which is sodium triiosocarbonate 4. Okay, so molar concentration equal to mole over volume, which is in decimeter cube. So 500 centimeter cube, we have to convert to decimeter cube. 1000 centimeter cube is equal to 1 decimeter cube. So 500 centimeter cube is equal to X. But we can know that this is 0.5 decimeter cube. But to prove it, we have to solve it by just normal cross multiplication methods, which is 0.5 decimeter cube. So you see, so we write out the formula and then we say 0.1 molar concentration equal to N over 0.5. So now we have calculated the mole out. Now from the mole, we can now find the mass, okay, which is reacting mass over molar mass. So if 0.005 mole is X all over, now we have to get the molar mass. So we are calculating the relative molecular mass of sodium triiosocarbonate, which is 106. So we find out what X is, and that will be the mass of this compound in the reaction. Thanks for watching the video. If you love the video, don't hesitate to smash the like button and subscribe for more Jamb chemistry videos like this. Bye. See you later.